Hello, welcome to the Optimist Lab. In this video, we'll be talking about the kinetic theory of gas. That is, the set of laws that bind what? That bind the behavior of what? Of our gases. Note, in this topic, we are going to be basically talking about ideal gases as covered by the syllabus. Let's dive in. Okay, what are the objectives of our video today, of our lesson? You should, at the end of this video, you should be able to derive and apply the gas law using the assumption of the what? Of the kinetic molecular theory. You should be able to use the kinetic theory to explain the what? The deviation of real gases from what? From ideal behavior. And you should be able to solve what? Questions and develop what? Critical thinking skills. And you should be able to apply what? Different methods and different formulas to solve practical problems as they are going to appear in your upcoming UTME exam. Let's go. Okay, before we dive in totally, let's quickly take a quick recap of the topic itself. So, this is a question for you. Do you know what actually causes the pressure of the gas inside the container? Think about it. What do you think causes it? We say that gases has pressure. Okay, cylinder has pressure, cylinder has pressure. The local cylinder you are using to cook in your homes, they have pressure. They will say carry it very well, don't let it fall down. Things like that. Why do you think they have pressure? Okay, you are making something up. Yes, I'm listening. Okay. So, the reason why, pressure is defined as the what? As the ratio of force per unit area, right? So, gases, as we all know, they move randomly, right? They have the freedom of movement, unlike liquid that slide over each other and solid that only vibrate. Gases has the ability to move around. So, as gas molecules are moving around, and they are moving randomly, they are not moving in a particular direction, they are going to what? There is going to be collision between gas molecules. The collision between gas molecules and the wall of the container of the gas is what generates the what? Is what generates the pressure. That's why one of the kinetic theory of gas says that what? The collision between what? Between gas molecule and the wall of the container is what? Is perfectly elastic. So when they collide, they do not lose momentum, neither do they lose what? Kinetic energy. So the collision is what? Is infinite, it continues what? Infinitely. Because what? Neither do they lose momentum, nor do they lose what? Nor do they lose energy. So the collision continues into what? Into infinity. So it's the collision between gas molecule and the wall of the container that actually causes the what? The pressure we experience with what? Inside the gas cylinder. So another question for you. The question says that what happens to gas molecule when the temperature increases? Yes. Okay, what happens? I'm listening. Okay, you are right. Yes, one of the kinetic theory of gas is that what? The kinetic energy is the measure of the what? Of the average temperature. That is, as the temperature increases, the kinetic energy of the body is also going to increase. And as the kinetic energy of the body increases, the collision between the bodies are going to what? Are going to increase because they are going to move at a faster speed now. When the kinetic energy increases, we know that the kinetic energy is what? Is half mv square, right? And the mass of the what? The mass, we know that what? Our K, I want to try to explain the reason why the velocity increases is half mv square, right? Half mv square. So we already know that what? This is our m, the mass of the what? The mass of the gas, it will be a constant, it's not changing, right? So definitely if the kinetic energy increases, definitely it is the velocity that is going to what? That is going to follow suit. And as the velocity increases, the collision between gas molecules is also going to increase, thereby increasing the what? Increasing the pressure. I hope you get that. Okay. In this video, I've mentioned two assumptions of the what? Of the 5 assumptions of gas, of the kinetic theory of gas. So can you tell me the other 3? The other 3 assumptions of kinetic theory of gas. Oh yeah, I'm waiting. Okay? Are you trying to say the correlation between gas molecules is perfectly elastic? No, I'm not taking that because I've said that before. So that we count that as 1. Okay? Okay, yes, thank you. You said the force of attraction between gas molecule is what? Is negligible. Yes, that's also part of it. We count that as 2. Okay, can you come up with another one? The collision between gas molecule is perfectly elastic. 3. Yes, you're right. And number 4, kinetic energy is a measure of the average temperature. Yes, you're also right. Although I've said that before. Okay, can you give me the last one? I've talked about the last one also in this video. Okay, the motion of what? Of gases is what? Gases move what? In random motion. They just move all around without direction. They can go like this. They can be going like this, and they start to change. They change. They do not have what? A particular direction with which what? They are moving towards. So that is what? That is that about that. Now let's take a look at some sample question from the what? From the UTME past questions. These are the type of questions you are going to see in your exam. And let's try to solve them together. So the first question here is saying that which of the following is correct? The first one says the average kinetic energy of a gas is inversely proportional to its temperature. Do you think that's right? Taking a look at the kinetic theory of gas, it says that the temperature is a measure of the average kinetic energy, meaning that they are direct proportional. But this one is saying they are inversely proportional. Definitely, this particular option is not correct because of the what? Because of the presence of this inversely proportionality. We move to the next one. At constant temperature, the volume of a gas increases as the pressure decreases. Okay. For the volume to increase while the pressure decreases, for the volume to increase while the pressure decreases, that is, the volume increase while the pressure decrease, it means that what? They are inversely proportional to each other. They are inversely proportional to each other. And that is giving me a vibe of a particular what? Of a particular gas law. What do you think that gas law is? Yes, you are right. That is the what? That is the Boyle's law. That is, this is also going to give us what? Our P is equals to what? Is equals to K over V. Right? Our P is equals to K all over V. And this will later give us what? PV. This will give us our PV. Our PV is equals to AK. AK. So if our PV is equals to AK, so we can definitely say what? P1 V1 is equals to what? Is equals to P2 V2. And this is what? This is the formula for Boyle's law at what? At a constant temperature, right? So since this particular option is right, let's check other ones. The pressure of a gas is directly proportional to volume. No, this is already what? This is already against the Boyle's law that we just stated. The temperature of a gas is inversely proportional to its volume. Inverse proportionality? Is that all right? No. Because the Charles law states that what? The temperature T the temperature T is directly proportional to volume at what? At constant pressure. The collision of gas molecules with each other is inelastic. Definitely not, because of the gas theory we state that what? The collision between the gas molecule and the wall of the container is perfectly elastic. Therefore, the perfect answer for this question will be what? Our option B, because it's what? Is directly states the what? The Boyle's law. Moving on, the second question is saying something nice. 30 cm cube of oxygen gas diffuses through a porous spot in 7 seconds. How long will it take 60 cm cube of chlorine gas to diffuse through the same pot? The vapor density of oxygen and chlorine at 16 and 36 respectively. This particular question is talking about what law in the what? Under the kinetic theory, under the chemical, the law of gas, the gas laws. Okay, I'm listening. What do you call it? Yes, definitely. It's talking about the what? The Graham's law of diffusion. The Graham's law of diffusion. The Graham's law of diffusion. Can you please state the Graham's law of diffusion for me? Okay. The Graham's law of diffusion states that what? At constant temperature, yes, thank you. The rate of diffusion is what? Is inversely proportional to the what? To the square root of the density of what? Of that particular gas. Is that fine? So if we play around this particular variation, we can get our R1, over R2 to be equals to what? To be equals to the density, the square root of the density of the second gas, of the density of the second gas, all over that of the first gas. Right? So now, our rate for the oxygen gas will be what? The volume over time. So we can still play around with this formula. If you want to use this treat, you can have our V1 T2 all over V2 T1 is equals to the square root of what? Of densities, of the ratio of the densities. So I think we can just use this straight. To get our answer. So we are going to have what? If V1 is 30 multiply by the T we are looking for over 60 multiply by 7 is equals to the square root of 36 over 16. So we have 4 can go here. 2 can go here to give us 8. 2 here will give us 18. So we can still divide again. This will give us 4, right? And this give us 9. This will give us 9. So this 30 here to give us 2, 30 here 1. So we can have this. You can have T. We can have T over 2 times 4 is 14 over 14. T over 14 to be equals to T over 14 to be equals to what? The square root of 9 all over 4. Since we know the square root of 9 to be 3, so this should be equals to 3 over 2. So if that is equals to 3 over 2, we can cross multiply. So we are going to have, if you cross multiply from T over 14 equals to 3 over 2, this 14 is going to multiply this 3. So we are going to have our T to be equals to 14 multiplied by 3 all over 2, right? This 2 here 1, 2 in 14, that's 7. So we are going to be having 7 multiplied by 3. That will give us what? 21. So the answer to this particular question is what? Is 21. Moving on. The next question is saying something nice. The normal boiling point of a liquid is defined as that. What is boiling point? Okay, before you even check the option at all, what is boiling point? Boiling point is the temperature at which what? The saturated pressure of a what? Of a particular liquid equals the what? The atmospheric pressure. That is, the two pressures are the same. That is what? That is the boiling point. Let's now take the option. The temperature at which the vapor pressure equals the atmospheric pressure. The temperature at which bubble begins to form. No. The temperature at which the vapor pressure at which the vapor equals the rate of evaporation of the liquid. No. The temperature at which the space above. No. So the correct option here is what? Our option A. So the next question is saying that under high pressure, real gas do not obey gas law because their molecule dash become more energetic, become less energetic, become smaller in size, decompose into atoms, start repelling each other. What do you think the answer is? Okay, I think you are saying something. Let's see what probably you are right. So one of the theory of gas is that what? The force of attraction and repulsion between gas molecules is negligible, right? But under high pressure, gas molecules are forced to what? Into a smaller area, causing them to what? To react with each other more. This results into what? This results into as the volume decreases, the intermolecular force that was initially negligible become more significant, thereby making it easy for the gases to what? For the gas molecule to repel each other, because what? The intermolecular force is now what? Is now more significant. So the perfect answer for this particular question will be what? They start to repel each other. So the next question is saying that 500 cm³ of oxygen was collected over water at 30 degrees C and 752 what? Atmospheric of millimeter mercury. What is the volume of the dry oxygen at STP? Given that vapor pressure of oxygen at 30 degrees 32 millimeter mercury. So whenever you are given a question like this, the total pressure given is equals to the what? The total pressure given is equals to the what? To the pressure is equals to the pressure of what? Of the gas plus what? Plus the vapor pressure, PV. Do we get that? So, in order to do any calculation, we cannot use the total pressure because the total pressure is not the exact pressure we need. We need to remove the what? The vapor pressure from it. So the pressure we are going to use, here, it will be what? This 752 minus this what? Minus this 32. So 752 minus 32, that should give us what? 720. So our normal P that we are going to use in calculation is what? Is 720. 720. So now, let's see, which of the laws are we going to use? We are considering the volume and the what? And the pressure. So that's Boyle's law. P1 V1, right? P1 V1 is equals to P2 V2, right? So what's our P1 now? Our P1 is 720 multiplied by, what's the volume initially? Okay, 500. So at STP, the pressure will be what? 760, right? So if we divide both sides by P2, so we are going to have what? This to be divided by what? The 760. So we can do something nice here. This 0 can go, right? Then we can quickly divide the rest. So that will give us what? That will give us 473.6. 473.6. So the closest answer here is what? Is this option A. So the next question is saying that which of the following statements is an exception in the assumption of what? Kinetic theory of gas. That is what? Is not in alignment with the what? With the kinetic theory of gas. The first one is saying that what? Gases are compounded of many elastic what? Elastic particles. That should be right because what? The collision between gas molecules is perfectly elastic. The particles are of negligible size. Yes, that's also right. The particles are in constant random motion. That's also part of the theory as we stated. The particle, okay. The particles collide with each other, yes, but we never state that what? The particle has negligible mass. Because if they have negligible mass, their what? Their kinetic energy will also be what? Will also be negligible. Because kinetic energy is what? Is half what? Half mv squared. So the mass is what? Is important in what? In kinetic energy. And we said the gases has what? Kinetic energy. Definitely their mass cannot be what? Their mass cannot be negligible. Definitely that is our what? That is our answer for this particular question. Moving on. The next question said, on heating, under suitable condition, 1 liter of molar atomic gas combined with what? 1.5 liter of oxygen to form an oxide. What is the formula of the oxide? That is what they are saying. 1x. Avogadro's law states that what? Equal volume of all the gases contains equal numbers of molecules. Definitely, we can what? Equate this volume to what? To number of what? Number of molecules. That is, the number of molecule can also be what? Can also be assumed to be the number of mole. If the number, because we are going to divide the two of them by the what? By the same Avogadro's constant. So you can say we have 1 mole of this and what? And 1.5 mole of what? Of oxygen, right? 1.5 mole of what? Of oxygen. But since we cannot write a chemical formula with what? With decimal, we can look for a way to convert this to what? To whole number. So we can multiply through by 2. So this will give us 2 and this will give us what? This will give us 3. So definitely the answer will be what? X 2 O 3, which is what? Option C. So the next one is saying that when air is compressed, dash happen. What happens? When air is compressed, that is what? The volume what? Decreases, right? If the volume decreases, the collision between gas molecule will what? Will increase. And if the collision increases, the kinetic energy will what? Will increase, right? And we already said the what? The kinetic energy is a measure of the what? Of the temperature. Definitely, as the kinetic energy increases, the temperature will also do what? The temperature will also increase. So the answer to this one is what? Our option C. So the next question is saying that 28.8 cm cube of nitrogen at 15 degrees C is cooled to what? Is cooled at 0 degrees C at constant pressure. The new volume of nitrogen is dash. What we need to consider here is that what? We are comparing volume and what? And temperature. And the law that compare volume and temperature states that what? The volume is directly proportional to the what? It's directly proportional to what? To the temperature. And that is what? The Charles law at constant what? At constant temperature, at constant pressure, right? That's the Charles law. So, if the Charles law states this, the formula for Charles law is what? V1 over T1, V1 over T1 is equals to V2 all over T2, right? So we have our V1 already, we have our T1 already, we have our T2, we are looking for V2. So our V2 is what? V1, right? T2 over T1, right? What's our V2? Our V1, Joy. The V1 is 28. The V1 is 28.8, right? Multiply by the V2 is 0 degree, that's 273. Multiply by 273 divided by 15 plus 273, that's what? That's 288. That's 288. That's 288. This 28.8, this 288. So 28.8 here 1, 28.8 here what? That's 10. The 10 divided by this will give us what? 27.3. Option what? Option C. next question is saying that, what is the partial pressure of hydrogen gas collected over water at standard atmospheric pressure and 25 degrees if the saturated vapor pressure of of water is 23 millimeter mercury at that temperature? This law is particularly referring to a particular law. This question is referring to a particular law that we call the what? The Dalton's law of what? Of partial pressure. It states that what? If gases in a mixture of gas that do not react together chemically, the total pressure is the sum of the what? Of the individual pressure of the what? Of the gas. That is, here that we have hydrogen and what? And water. The total pressure will be what? The pressure of what? The pressure of hydrogen gas. The pressure of hydrogen gas. Plus that of what? Plus that of the pressure of what? Of water. So here now, we are looking for the what? For the partial pressure of what? Of the hydrogen gas. The total pressure will be 760, right? And they have given us the one for water to be this, right? So what we are going to do is to just what? Remove this from what? 760. So we are going to have what? 760, which is what? The atmospheric pressure, the total pressure, minus what? 23. And that is going to give us what? That is going to give us 737, right? So the answer will be what? The answer will be option A. Okay, moving on. The next question is saying that if a gas occupies a container of 146 cm3 at 18 degrees and 0.9718 atm, its volume at STP is dash. So this particular question, we are going to be applying the what? The general gas equation, that is what? The P1 V1 all over T1, right? Is equals to P2 V2 all over T2. So in this particular question, we are looking for the V2. So we can cross multiply and divide. So our V2, if we cross multiply, then we divide both sides, will be what? P1 V1 T2 all over P2. T1. This is what we have. Now let's input our values. Our V2 will now be equals to, what's our P1? That's 0.971, right? Multiply by what? What's our V1? The V1 here is what? 146. 146 multiplied by, what's the temperature here? The temperature 2 is the what? Is that STP, that's 273. 273 divided by the P2 is at STP, so it will be 1 atm multiplied by the T1, that will be 273 plus 18, right? That will give us what? 291. So if you compute this, your V2 should be that's 132.99, approximately what? 133 cm cube, and that will be what? Option A. That will be our option A. So the next question is saying that the volume occupied by 158 grams of a what? Of a gas at 500 cm cube is dish is 1.58. What is the relative atomic mass of the gas? The relative atomic mass of a particular gas is the same thing as the volume occupied by the gas at what? At its molar. It's the same thing as the mass of the gas at its molar volume, right? So, and we already have the molar volume here to be what? 2,400. So the only thing we need to find is what? Is the number of what? The number of mole. So the number of mole will be what? Volume over what? Over molar volume. The number of mole is going to be volume over molar volume. That will be 500 over what? Over 22,400. 22,400. And that will give us what? That will give us 0.0223. So now we also know the number of mole is equal to what? Mass over molar mass, right? So the molar mass that we are looking for will be same thing as what? As the mass, our mass M, over what? Over the number of mole. So that will give us what? This 1.58, 1.58 over 0.0223. And that will give us what? That will give us 70.78. Approximately what? 71. 70.78. That will be what? Option D. Right? To a room at the same point and time, which of the following gives the order of division of gas to the opposite corner of the room? from the Graham's law of division, we know that what the rate of division is inversely proportional to the what? To the square root of what? To the square root of the density. Is inversely proportional to the square root of density. That is, the heavier the gas, the slower it's going to move. So now let's rate these gases in terms of their what? In terms of their heaviness. CO, that is 12 plus 16. 12 plus 16. That's 28. 28. SO2 is 64. 64. NO2, that's 14 plus 32. That's 46. That's 46. And H2S is what? That's 34. So if you take a good look at this, we are going to see that what? SO2 is the heaviest, right? That's 1, followed by what? NO2, that's 2, followed by what? H2S, that's 3, and then what? CO, that's 4. So since CO is the what? Is the lightest, definitely it will be the what? It will be the fastest. So it will be what? CO is greater than what? H2S is greater than what? NO2, then greater than what? SO2. So now let's see the one that follows that trend. CO greater than what? H2S greater than what? NO2 greater than what? SO2. Definitely this will be the answer. This is wrong because what? H2S is not the what? Is not the heaviest gas. And here too, CO is not the heaviest gas. That is, it is going to have the highest speed. It cannot have the lowest speed. CO cannot have the lowest speed also. So this one is also wrong. So then moving on. A basic postulate of the kinetic theory of gas is that the collision of gas molecules are perfectly elastic. Yes. This means that what? Molecules can occupy any volume. No. Kinetic energy is conserved. Yes. All molecules have the same speed. Not necessary. The force of repulsion and attraction and equilibrium. For every collision, we have two types of collision. We have what? The elastic collision. We have the elastic collision, and what? And the inelastic collision. We also have the inelastic collision. The inelastic. We also have the inelastic. For the elastic collision, both kinetic energy and what? And momentum is conserved. But for inelastic collision, only the momentum is what? Only the momentum is conserved. So you should note that. So for this particular question, the best answer is what? The kinetic energy is what? Is conserved. That is what? They did not lose what? Any energy when they what? When they collide together. Which of the following gases can be collected by upward displacement of air? For us to collect a gas by upward displacement of air, for us to collect a gas by what? Upward displacement. Upward displacement is also the same thing as what? Downward delivery. They can call it upward displacement or downward delivery. The two are the same. For us to collect a gas by upward displacement, the mass of that gas must be what? Must be lesser than the what? The weight of air. And that is what? The weight of air is approximately 29. 29 is approximately 29 grams per mole. Approximately 29 grams per mole. So it must be what? It must be lesser than this. it must be lesser than this. If it is greater, therefore it will be what? Downward displacement, upward delivery. So let's see which one is less than that. NO2 here, NO2 is 32 plus 14, that's 46. H2 is 2. Okay, I think this should be H2O, not H2. This should be H2O. So H2O, okay. Okay, we have H2O. So the next question is, which of the following gas can be collected by upward delivery? Upward delivery is also the same thing as what? It will be the same answer also if they say what? Downward displacement. And if you upward displacement, downward delivery, the answer is going to be the same. So for us to like get a gas, collect a gas by upward delivery, the mass of the gas should be lesser than what? That of air. And the mass of air is approximately what? 29 gram per mole. 29 gram per mole. So if it is 29 gram per mole, let's check. This is NO2 is greater than 29 because O2, ordinary O2 is 32 and we add 14 to it, that's 46. H2 is less than 29. NH3 is less than 29 because that's 14 plus 3. This one is 71, is greater. So we have H2 and what? NH3. So the two are the our potential answer. But our final answer is going to be what? Option C. Why? Because what? H2 is insoluble in what? Is insoluble in water. So it is collected by what? Downward. It is collected by downward displacement of water. It's collected by downward displacement of water. Moving on. The next question is saying that 30 cm cube of oxygen at 10 atmospheric pressure is placed in a container of what? 200 cm cube. Calculate the new pressure if temperature is constant. So this particular question is making use of the what? Of the Boyle's law, right? And we already know the Boyle's law formula to be what? P1 V1 is equals to P2 V2, right? So we are having 300 multiply by 10 is equals to 200 times what? Multiply by x, right? So we are dividing both sides by what? By 200, right? So 200 is cancelling out this. So these two zeros are cancelling out this. So 3 times 10 is what? Is 30. 30 divided by 2 is 15. So the answer for this one is what? Option B. A given quantity of gas occupies a volume of 228 cm cube at a pressure of what? 750 millimeter mercury. What will be its new volume at atmospheric pressure? So it's the same thing. We are looking for V2 again. So we can just make V2 the subject of formula. That will be what? P1 V1 over what? That should be over P2. Over P2, yes. So we're having what now? That's 2, that's 228 times 750 times 750 all over. The atmospheric pressure is what? Is 760. 760. So the answer will be what? 225 is equals to what? Is equals to 225. So option what? Option B. A sample of gas exerts a pressure of 8.2 atm when confined in a what? In a volume of what? 2.93 dm cube container at what? At 20 degrees. The number of mole of the gas in the sample is dash. So this one you are going to use the what? The general gas equation for it. That is what? PV equals to what? PV equals to nRT. And we have been given the value of our R, and we are looking for our number of mole. So we just need to make the number of mole the subject of formula first, after which we are going to play around with the form. We are going to input our what? Our values. So making the number of mole the subject of formula, we are going to have PV all over RT. And don't forget, whenever you are solving what? Under gas law, or what? All temperature are in what? Are in absolute value. So we are going to have this to be equals to what? This to be what? 8.2 multiplied by 2.93 divided by 0.082 multiplied by, this will be 20 plus what? 273, that's 293. 293. So this is 2.93, right? 2.93 here, 1, right? 2.93 in 293, that's what? 100. If you count this, 1, 2. So 0.082 here, 1. 0.082 in 82, in 8.2, that's another what? 100, right? 100 is going to cancel out 100, and we're going to have our final answer to be what? 1. Moving on. The next question is saying that a given mass of gas occupies 2 dm cube at 300 Kelvin. At what temperature will its volume double, keeping the what? Keeping the pressure constant. That is, we are looking for the temperature at which V2, the temperature at which what? V2 will be equals to what? Twice of what? Of V1, right? So this is Charles' law, which says that what? The volume is directly proportional to the what? The volume is directly proportional to the temperature, right? That is V1 over T1 is equals to V2 all over T2, right? So here we are looking for T2. So our T2 will be equals to what? V1. No. It will be V2 T1 V2 T1 all over V1, right? So that will give us what? The V2 is twice of V1. That is, V1 is what? V1 is 2. So twice of 2 is going to be what? 4 times 300 all over 2. 2 here 1, 2 here 2. 2 times 300, that's what? 600. Which of the following is a measure of the what? Average kinetic energy of the substance? If you don't for one of the kinetic theory of gas state that what? The temperature is a measure of the what? Is a measure of the average kinetic energy. Definitely the answer here will be what? Temperature. Moving on, an increase in volume of a given mass of gas at constant temperature produce a corresponding increase in the what? Let's check. Volume of the gas? No, because what? Boyle's law states that the volume is inversely proportional to the what? To the pressure. As the pressure is increasing, the volume is going to be reducing. The number of molecules per unit area. The number of molecules per unit area since the volume is decreasing, the number of molecules per unit area will also increase. And the number of collision, because the volume has decreased and the number of molecules within a particular area has increased, the number of collision between the molecules will also increase. So definitely these two are correct here. The two are correct. And the number of molecule between the walls of the container, this one is always constant. But what? These two, they are the same. They are almost the same thing. Number of collision per unit area and number of collision between molecules, the two increases because what? Volume has reduced. But if you have to go for one, the best one is to go for what? Option B. At 27 degrees C and 1.5 atm, what volume will it occupy at STP? At STP, we know the temperature is what? At STP, the temperature is at STP, we know the temperature is what? 273 Kelvin, and the pressure is what? 1 atm, right? So for this question, we're going to use the what? The general gas equation, right? So that will be what? P1 V1 T2, right? all over P2 T1, right? So let's input this. The first pressure is what? 1.5 multiplied by what? 4.5 multiplied by 4.5, then multiply by what? What is the T2? That's 273, right? That's 273. 273. Everything divided by A. Everything divided by P2. What's P2 now? 1 multiplied by the T1 is what? Is 27 degrees. So we are going to add 273 to it, right? To convert it to Kelvin. That's 300. 300. So if you compute this, you should get you should get 6.0 dm cube, which is option what? Which is option C. So the next one is asking that which graph does this represent? So we need to know if they are plotting, if you have volume, if you have temperature, if you have volume against temperature in Kelvin, against temperature in Kelvin, this is going to be what? That will be Charles' law. But if you have volume against what? An inverse of pressure, against an inverse of pressure, that will be what? Charles' law. So the next one, if D represents the density of a gas and K is a constant, the rate of gaseous diffusion is related by which of the equation? As according to what we know from Graham's law of diffusion is what? It is inversely proportional to the what? To the square root. So definitely R will be what? K over the square root of D. And the best answer here is what? Option A. Okay. The next one is saying that it can be deduced from the vapor pressure curve above that okay, moving on. This question is saying that it can be deduced from the what? From the vapor pressure curve that. Let's take a look at the vapor pressure curve. This is vapor pressure. This is the temperature. And we have here, this is where this particular liquid boils. This is where this particular liquid boils. And this is where this particular liquid boils, right? Okay, liquid A has the highest boiling point. That's a lie. Liquid A has the lowest. Liquid 2 has the highest boiling point. That's also a lie. It has the what? The medium. And liquid 3 has the highest. That's correct. That's the what? That's correct because it's boil at what? At around 100 degrees. So moving on, it's saying that which of the following curve, represent that? Which of the curve in the above graph illustrate the behavior of an ideal gas? Ideal gas Ideal gases are said to be ideal at what? At high pressure and what? And low temperature. And they are said to what? To deviate ideality at what? Low pressure and what? And high temperature. So for a gas to be ideal, it is going to follow what? All gas laws. And the one that have what? A straight line graph, or from the what? From the graph that we have here is what? Is W. Is the only one that does not have deviation, unlike others. So the best answer here is going to be what? Option what? A. Because that's the only gas that what? That follows the gas law. And any gas that follows the gas law is what? Is an ideal gas. The minimum volume of oxygen required for the complete combustion of mixture of 100 cm cube of CO and 15 cm cube of H2O is dash. So, if CO is burning in oxygen, let's write the equation of reaction. Plus O2 to give what? To give us 2CO2. So to balance the equation, we are going to put 2 here, right? So let's look for, that is for every volume of oxygen, we are going to require what? 2 volume of what? Of CO. What is the volume of oxygen that we of CO that we are giving here? We are giving 10, right? So if 2 of CO require 1 of what? Require 1 mole. Requires 1 mole of oxygen. Definitely 10 cm cube is going to require what? Our X. If you cross multiply, you are going to have what? 10 times 1 is 10 to be equals to what? To be equals to 2x, right? To be equals to 2x. And by the time you divide both sides by 2, and this side also by what? This side also by 2. So we are going to have our x. We are going to have our x to be equals to what? To be equals to 5. So the answer here will be what? 5 cm cube. And with that, we have been able to walk through 30 questions on the what? On the kinetic theory of gas. And by now, I believe you should be able to understand this particular topic and be able to tackle any other question around this topic. So, to help you check your knowledge and to prevent false confidence, we have created a quiz on this topic, and we have pinned the link to the quiz in the comment section. Kindly check it out. Thank you for watching, and see you next time. Until then, be fine. Bye.